Welcome to Morex University. Let's dive into deep learning. Today's topic is all about the basics of PLC. PLC stands for Programmable Logic Controller, also known as Programmable Controller. PLCs are solid-state members of the computer family using integrated circuits instead of electromechanical devices to implement control functions. They are capable of storing instructions such as sequencing, timing, counting, arithmetic, data manipulation, and communication. This is to control industrial machines and processes.
First things first, it started in 1968 that some engineers in the Hydromatic Division of General Motors Corporation issued a request for proposals for an electronic replacement for hardwired relay systems. The winning proposal came from Bedford Associates from Bedford, Massachusetts. The result was the first PLC, which was built in 1969 and designated as the Model 084 because it was Bedford Associates' 84th project. Bedford Associates started a company dedicated to developing, manufacturing, selling, and servicing this new product, which they named Modicon, acronym for Modular Digital Controller. One of the engineers who worked on that project was Richard Dick E. Morley, who considered to be the father of PLC. The Modicon brand was sold in 1977 to Gold Electronics and later to Schneider Electric, the current owner.
PLCs consist of input module, a central processing unit or CPU, and an output module. An input accepts a variety of digital or analog signals from various field devices or sensors and converts them into a logic signal that can be used by the CPU. The CPU makes decisions and executes control instructions based on program instructions in memory. Then the output module converts control instructions from the CPU into a digital or analog signal that can be used to control various field devices or actuators. The programming device is used to input the desired instructions. These instructions determine what the PLC will do for specific input. The operator interface device allows process information to be displayed and new control parameters to be entered. In this simplest example, push buttons as sensors connected to PLC inputs can be used to start and stop a motor, connected to a PLC through a motor starter as actuator. PLC works in a program scan cycle where it executes its program repeatedly. The simplest scan cycle consists of 3 steps: read inputs, execute the program, and write outputs. There are various brands now widely available in the market, and every brand has their own programming approach. So how do we program PLC? IEC 61131-3 standard specifies 5 distinct forms of programming language for industrial controllers. In this case, I categorize it to 3: textual, graphical, and chart. The said standard specifies the syntax and semantics of 2 textual languages, instruction list and structured text, and 2 graphical languages, ladder diagram and function block diagram, and 1 sequential function chart. While ladder diagram is the oldest and most popular language used in PLCs today, many other languages are gaining in popularity, are in wide use.
PLCs are used in various applications in industries such as the food and beverage, cement manufacturing, automobile industry, wastewater treatment, and the energy sector. Having to utilize such controller enables precise, reliable, and faster production, lesser maintenance costs, and space efficient. One advantage of PLCs that simply cannot be duplicated by electromechanical relays is remote monitoring and control using digital computer networks. As you opt to automate your process and consider to use PLC, I hope you find this learning video valuable.